Hello everyone, I'm Caroline and I will be one of the instructors for the animation tutorial as a part of Studio's creative track. I'll be covering the first half of this tutorial with 2D animation, and Athena will later on cover 3D animation. So first off, let's clarify what animation is. Animation is essentially a method in which figures are manipulated to appear as moving images. In terms of 2D animation, there are two main ways you can approach this method: frame by frame animation and rigging animation, which is also sometimes called tweening. In terms of character animation, you'll have to consider all sorts of cycles you'll need to make your character move around and live in its environment, creating walk cycles, sprint cycles, idle animation, and any other movements like jumping or rolling all help bring your character to life. With the example animation image given here, you can see that there are 8 essential frames that make up a successful walk cycle, even though there are actually 9 right here. The last frame here called contact is actually just a repeat of the first frame here to show that the walk cycle loops around. After that, you can split these 8 frames into 2 halves, and you'll notice that the first half from 1 through 4, contact, recoil, passing, and high point, are actually directly paired with the frames of the second half: contact, recoil, passing, high point again. The only real difference here is that the limbs are switched around. So you can see that, for example, in the contact frame, this left arm is no longer behind, it's in front, and the right arm is swapped around again. So this just repeats so forth. So once you put all these frames together, it will look something like this. And ta-da, you have yourself a walk cycle. It's important to note that whether you're using frame by frame animation or 2D rigging, this is still helpful to keep in mind. Obviously, this example is frame by frame, but even when you are doing rigging, you should be setting your keyframes to these positions relatively so that once you put it all together, the computer will generate some form that looks like this walk cycle. So next we'll delve back into what I was talking about previously in terms of the two main methods of 2D animation. Frame by frame animation is generally recognized as more traditional. It's very recognizable and has a very nostalgic feel to it. Think Disney animation in the 80s or 90s. The benefits of using frame by frame animation is that it gives you more control of what you want. So whatever you want to do with the character's actions or environment's movement is basically entirely in your hands. However, the downside is that it takes exponentially more time since each frame does have to be hand drawn. The other option you have is rigging. The downside to this method is that it's limited by the rig. It's not like frame by frame animation where you can have complete creative control. However, rigging has become more and more common for its benefits. For instance, it's significantly faster than frame by frame animation and relatively simple. Rigging also tends to have smoother results as the frames in between the keyframes you set are automatically generated by the computer. So on the left here, you can see a frame by frame whooper and a rigged whooper. The frame by frame whooper has a more dramatic bounce to it, and then the rigged whooper's movements are a lot smoother. So now we can actually move forward and get started with the 2D animation rigging in Unity. So first off, we can make sure that we have all the correct packages downloaded. So you can open up the package manager and just make sure you have both 2D animation and 2D PSD importer all installed. Since Unity 2020 version now includes 2DIK inside the 2D animation package, you no longer need that installed separately. So now you can open up, make sure you have the character example PSB file downloaded and inside your assets folder. You can find this file in the creative tutorial GitHub repo. If you have any trouble finding that, that should be in the description of the video. So now you can open up the Sprite Editor. When creating the character asset for the purpose of 2D rigging, You should keep in mind that any separate part of the body you want to move around should be on a separate layer. For example, the head, the body, the limbs, the hips, basically anything you want to move around should be on a separate layer. Since we're using a PSB file, it conveniently separates all the layers of a Photoshop file automatically for you. But if you want to use a PNG, make sure you have all of these separate body parts laid out in a sprite sheet rather than having it stacked on top of one another. So to get started, make sure you have the sprite mode selected as multiple and then check the box next to character rig. You can also make sure that all of these body parts are correctly configured, and if they're not, you can drag these edges. But since it looks about right on this screen, we can get started and open up the skinning editor. So the skinning editor is actually what will allow you to prepare your character for rigging. As you can see, since we are using a PSB file, the skinning editor will automatically place all the body parts in their correct locations. So to start off, you can start creating a bone, and I'm gonna create a bone for the hip. You can just left click and you can see that the bone will follow you wherever you drag your mouse. So one for the hip, one for the chest area, neck, and then head. And then in order to stop this chain of bones, you can just right click. And then in order to get started with creating the bones for the limbs, you should keep in mind that while the bones of the limbs should be connected to the chest and body, there should not be a direct bone connecting them. So in order to do this, you can left click on the chest bone, which is just the nearest bone to the limbs. And then you can see that there's this transparent icon, and that will actually show that it's parented to the bone you're about to create. So now I'll just create one for the right arm, for the upper arm, and the lower arm. Right click to end that. And then you can do that again for the other limbs. And then for the legs, you'll do the same thing. So now if you preview the pose, you can see that even though you're moving around these bones, you're not actually editing the sprite. So in order to get started, you can click auto geometry and then make sure weights is checked off and generate for all visible. And you can see this colorful mesh that appears behind the sprite. And you can see that when you're moving your bones around, the sprite actually moves with it. There's a lot of wonky spots like this, but we can fix that in a moment. First off, if you would like to edit the geometry at all, because there are some edges that you don't think are clean, you can click that and actually drag the vertices however you would like. We don't need to be too precise about this for now, since the model is not super detailed, but if you would like to clean it up, feel free to do that. If you would like to create a vertex when you're editing the geometry, you can actually click create vertex here, and just, for example, you want to drag this in, you can just left click and do it like that. You can also create edges and split edges if you want to get more detailed. Now, if you want to fix the issues of the strange issues like this, then you can click on bone influence, and for example, if you want to stop this from happening, then you can select the body, the sprite of the body right here. And you can click this bone, for example, bone 7 here, and just subtract it, as well as this bone. And you can see that now, if you lift this arm, it no longer drags up the sprite of the body. So you can do that with the other arm here as well. So you just subtract these. Oh, well, that was never influencing it. To get more detailed with bone influence, you can also use weight sliders as well as weight brushes. Weight sliders are a little less detailed, but essentially they have the same idea. So let's say you select this body sprite and you want to decide how much this bone affects it, then you can slide it around and decide, I don't want it to affect it at all, or you want it to be the only bone that affects it. So I'm going to leave mine around here. And then you can also use weight brushes, which has the same idea as a weight slider, but instead of using a slider, you can just manually paint on bone influences. You can increase the hardness of the brush, increase the size of the brush, as well as the step, and just paint on any influences you would like. So now if you preview the pose, things are working a little bit more smoother, although there are still weird interactions like that. So again, just go to bone influence, select the head bone, and subtract this bone from its influence, and you will no longer have the weird neck crush effect. So now if we preview the pose, you can see that everything is working a lot smoother. You can pose this character however you would like, basically. And yeah. Oh wait, make sure you apply the changes in the skinning editor. And you can drag your character in. And so finally, we're going to be creating some inverse kinematics or IK solvers. These solvers are essentially responsible for making any necessary calculations that might make animating a bit easier and smoother. So we're going to be creating 4 limb solvers as an example. So to start off, you can press add component and search up IK manager. Click the plus sign over here and add a limb solver. Next, you can create an empty object under the character's left arm's lowest bone. So you can just select this bone, which appears as bone 6, and then create an empty object. And we can name this object left arm effector for now. And then you can drag the target to right under the bone of the lower arm. Then you can click back on this solver, which I will rename left arm solver. So, and you can effectively pair this to the effector and then create a target. And then you can see that when you drag around this point, the entire limb moves with it. And it's flipped right now, so you can actually just press flip and it will solve that issue for you. And then now we can repeat these steps with all of the rest of the limbs. And so now you've created all 4 of the IK solvers. And when you are creating the keyframes for a pose of the character, these solvers will make it a lot easier so you don't have to move two bones at once. And now I will be passing it off to Athena, who will be talking about 3D animation.
Okay, so welcome guys. This will be the 3D portion of the 2D and 3D animation tutorial. Sorry about getting this out so late. But yeah, we're just gonna get started. So first you're going to right click here and just grab this package. So just click download. And then you should save it. And then as that is going, you want to create a new project in Unity. You can name this whatever. I'm gonna just name this 3D tutorial for brevity's sake. You want it to be the 3D core template with some variation of 2020.3 LTS. It doesn't have to be 19F1, but some version. Cool. And then you're just gonna click create project. Now that you have it downloaded, and just ignore all of this. I'm just gonna ignore that real quick. And then go to wherever you downloaded the package. And we can just drag and drop to import. So just drag and drop this to import it. You should see a bunch of these things. Yeah, ignore the warning, don't worry about it, and then just click import. It should import everything. Cool. Yeah, so you should see something with scenes. We're just gonna navigate to the tutorial scene. What you should see is a big, wide open, empty plane with an Xbot idle inside. So this is what you should see. So you should see this Xbot slash idle animation. But before we really dive into exactly what's happening here, we're going to talk a little bit about animation, where it falls into the whole, like 3D game or 3D development pipeline, and the individual components of 3D animation as well, just to give you a better sense of exactly what I'm teaching you, and where that would apply, and if you wanted to expand your knowledge in this field, what you might need to look into. So I have a couple of images. The first one is this. These are the different stages of 3D production. Is probably the best way to put it. You'll see that in the actual production level, there are 4 different things, but the main ones would be modeling, rigging, and animation. I am going to be teaching you animation and animations exclusively, simply because modeling and rigging is not something that you do within game development engines. It's also not something that you need to immediately start game developing. But animation is definitely needed if you need to develop games, and you want to make sure that things are reading properly. A little bit of an explanation of these individual sections. Modeling is the actual act of drawing or sculpting things out. Like in ZBrush, you are given almost like a block of clay. You can create those models. These are things that like that program, ZBrush, Blender, and Maya do. Within those programs, you can also do something called rigging. What this is once you're given a fully sculpted 3D model, how do we make sure the hair moves the way that it should? That your wrist will bend, but not to the point that it breaks. That the character can blink and do facial expressions. This is what rigging is. It's setting up the specific skeletal structure of a 3D model, so when it comes time to animate it, it can be animated properly. It's not missing a spine or stuff like that. And then ultimately what animation is it takes a fully rigged model and it will apply certain transformations or transforms onto that model, and mimic movement. So if I'm trying to animate a walk cycle, I'll manipulate the thighs and the feet and the arms in such a way that it'll seem like a character is walking. Um, And then this cycle will like repeat until you get to the final product. But that's generally what this is. And yes, we will be focusing on animation. Um, Something else, before we jump into animation is we need to look at what exactly we're going to be animating. When you're going to be working with models in game, or if you want to maybe create your own models for games, there are specific things that you have to remember. There is a core sort of skeletal hierarchy that will be used for most generic humanoid models. And if you find a model that doesn't obey this sort of like traditional hierarchy, or you want to create a model that doesn't obey this kind of traditional hierarchy, you have to keep in mind that a lot of general use cases might not apply. An example of this that we're going to go into later is animation retargeting. If you create an animation that's a jump animation, that's generic, so follows this specific structure, and you want to apply it from, let's say, your generic humanoid to a giant who's maybe has two different chest, like skeleton components, or has multiple hip components, or has more divisions of arms and legs, it will not have the same behavior. So, a good beginner place to start with animation is this generic skeleton. Um, this skeleton will also determine what you can animate. I'm just going to go into a little bit about what this hierarchy exactly means. What this means is essentially everything starts at the hip joint. If you move the hip joint, you move everything else. You can think of this as parent-child relationships in Unity, object relationships in C++, if you're about that. And within art programs, you can think of this like if you're using layers or folders or groupings of objects. The parent of that grouping is going to have the effect on everything else underneath it. So your hip joint will affect everything, including upper leg, upper left leg, upper right leg, and chest. Your chest will affect everything here, but will not affect the legs, and so on and so forth. This is a generic structure for a model, or humanoid model. It is different for animals, of course. But yeah, if you want to get into modeling and animation, I highly just suggest following this. Cool. Now that we have established that, we're also essentially not going to be making and rigging our own models, right? We're focusing on animation here. And a very good site to focus on for that is a site called Miximo, .com. Miximo is essentially Adobe's overall animation library. It has a whole bunch of just generic animation and models that are very, very good to use. This is also a very good shortcut if, you need the models, but you don't want to actually do the animation for it. So here is how the site is split down. You have characters and you have animations. Animations are stuff that you see below, right? You have a bunch of these sort of whatever animations. They're applied to a bunch of whatever random animations. We can choose to have a specific character model. So if I'm going through here, and like, let's say I really want to use this guy, Abe. Oh, he was already loaded. If I really want to use this guy, Abe, I can click on that character, that model, sorry, in the character tab, and then move over to the animations tab. And here is when I can choose a specific, animation for this. So you'll see here that despite this dancing animation being applied to the Xbot model, if I click on it, you'll see that the animation has been retargeted to fit on Abe instead. So now our dear old Abe is dancing. The reason for this is again, I talked about, this generic skeleton hierarchy and animation retargeting because it follows a specific hierarchy. You can retarget anything to this. I'll also talk a little bit about the specific settings. you'll see on the side that there's like an enthusiasm, like setting and everything. Let me reload it. It's a little frozen. Um, there's like an enthusiasm setting. A lot of these are just settings that modify the core animation. So if I turn enthusiasm up, you see like he dances a lot wider. If I turn it down, it's like a lot more muted, dancing a lot more in place. And a lot of these will have custom settings. You'll see that overdrive controls the speed. But a few core things is this is actually like almost like a little workspace. You can click with your mouse to navigate around it. You can also see the skeleton. See, this is like the hierarchy that I was talking about. You can see the skeleton. You can, like pan around if you would so prefer. You can zoom in. All of these specific things. You can even pause on specific frames if you want. But yeah, so that's one kind of animation that we have. And you'll see that it's like very much in its own space. And now we're going to look at first let's actually look into the mirror. If you like click on it, you can also mirror the animation. Sorry, I forgot to mention that. Yeah, these are all just changes that you can apply to the base model, and you can look around the scene to see what those changes did. There is also another type of animation. Specifically a walk cycle or anything with motion. Let's use this one. You'll see that this model, when it walks, will walk across a specific area. This is called root motion, i.e. the animation itself has a bit of motion applied to it. So when you put it in game, if you have this animation, it's not going to walk in place. Like your animation will not, or your model will not walk in place. And this is independent of applying some kind of velocity or whatever within the engine, because this has root motion. If you want to turn this off because you want to do all of your movement and all that kind of stuff within like a script per se, you want to apply a velocity. What you're going to have to do is you're going to have to check in place. And in place, you'll see that now, yeah, like this model is walking just like in a few squares, so in place. You'll see that this in place option is an option for essentially all models with any kind of root motion / base motion to it. Cool. Now that we know that, the way that you can apply different animations to characters, what different parameters mean, and some critical factors, we're gonna look at some download properties. So if you click download, you're gonna see 4 different sort of parameters or properties show up. First, it's the format, sorry. You have a bunch of different FBX file formats. What exactly is that? So first of all, we're going to note that there is a specific FBX for Unity. If you're using Unity, always choose this one just because it's the most optimal for Unity. What an FBX is essentially it's a binary file. So it's just like a very compressed file that encodes all of the information about the skeleton, where it's moving, when it's moving, the hierarchy, that kind of stuff. So that's what an FBX file is. So when Unity receives that file, it knows, oh, okay, this is how the skeleton is supposed to be set up, this is how it's supposed to move, etc. A skin is essentially the model. So you can either import something or, you can either download something with the model or without the model. So let's say I really want to use Abe here as a character, I can download it with skin. However, if I want to use a bunch of animations with Abe in it, I only have to download one central animation with the skin, and everything else I can do without it, right? Because I already have the base model there. Cool. So those are those 2 options. Frames per second is probably familiar to a lot of people, especially those more maybe artistically inclined. But even though like animations like the ones that you see here are animated on the skeleton, right? It's still processed as frames per second, right? That's why FPS exists in games. That's when you have slow FPS, it looks like it's almost like a PowerPoint. So upping this frames per second just means how many more of those, frames are captured. And reducing it means, like reducing the amount of frames that are captured. Be careful with this, simply because reducing something can lead to a less accurate animation, right? There is more degree of movement between each frame. So be careful about that. Likewise, increasing the frames per second, um, you can run into the danger of having models that are way too large, right? Because you have to capture and record the transformations of that skeleton, the different coordinates and vertices of that skeleton for a lot more frames per second than your standard. So just be careful, use best judgment when it comes to these things. And another thing is keyframe reduction. This is similar to frames per second in that it deals with optimizing or not optimizing your animation. Keyframe reduction is essentially saying, let's say I have a wave animation and my hand only moves like maybe like 1 degree between two specific frames, pardon me. Unity will essentially, or sorry, Miximo will essentially look at that and be like, okay, so there's only 1 degree of difference. It's not large enough of a difference for me to care about keeping this frame in this animation. I'm gonna delete it. It's a way of, another way to think about it, it's a way of culling frames or parts of your animation that are too uniform to each other and saving space that way. We're just gonna keep it at none for now. And yeah, those are all of the settings, and you can download as you wish. So this will be very good for future projects that you want to work on. That is, however, not our focus, and just to save time, we've already set up all of the animations that you would, or sorry, all of the models that you would need, and their respective animations. So now we can navigate back to the scene. We have our Xbot at idle here. This is our core model. You can go into the, I believe, animations folder, and you can see this model right here. And yeah, this is what it looks like when you import something with skin, right? You're gonna see like a bunch of different parts to it, and then the final animation. If there is something without skin, let's look real quick. I believe no. Yes. So this is something that was imported without skin, just as an example. You'll notice that it has none of the model components. It just has the core sort of skeleton and then the animation itself. So you'll see if you look at the Xbot at idle object in your project, there is an idle animation associated with it. However, when you press play, we can press play here, you'll see that like even though the animation is looks like it's in its like first frame of the idle animation, right? It's not playing. It's like freezing. Um so why is this? The reason for this is even though there is an animation tied to an object, you need to have something that tells the the animation itself to run. Right? So the model is just a model in the scene, but you need something to say, okay, activate the idle animation. And what that is an animator. So what you're going to have to do is go to this project folder, so your animator folder in your project. Ignore the placeholder animation. That's only there to make sure the animator folder is here. Right click, go to create, click on Animator Controller. That's what you need. And we can name this like model animation, anything like that. Whatever you would so wish that would help you distinguish it. Then you can then apply it by simply dragging it to the Xbot at idle object in the hierarchy. Another way you can do this is you can click add component and then you can search animator and it'll bring it up. But we want to make sure it's in the animators folder, so we're just going to create it this way. Now that you have this, we now have the core object that's going to command all of the animations. The animator is something that tells things to animate. When should you animate? When should you stop animating? When should you move to another animation? And to view the window for that, so to view the window where all the decisions are made, we're going to go to Window, Animation, and Animator. So let's move this down here so we can see everything. On start, you should see what essentially says any state, entry, and exit. You'll see this when you click on an object with an animator applied. So, however, this, if we click play now, okay, let's click play now. You'll see that the animation still isn't applied, even though you gave it an animator. That's because you have the base object, but you don't have the instructions yet. So we need to add the idle animation to it. So what we can do, is we can go here to our animations, navigate down to our idle animation. And originally we can just drag and drop this in, right? The problem is if we drag and drop this in, we can try this right now. You'll see that the animation will play. Like, voila, we've done that. The problem is the animation will play once and then it will stop. However, we don't want it to stop after just like a second, right? We want it to keep on looping back and forth until, you know, the character is no longer idling anymore. Yeah, you'll see like it stopped right here. So to do this, what you'll see is when you click on the idle animation in your inspector, you'll notice that the loop time is set to unchecked, so it's not looping. And you can't seem to edit it from here. The reason for this is because this idle animation is directly tied to this object, it's considered a child of that object, and Unity does not like it when you edit child objects directly. You have to edit it through the parent. So what we're going to do is here, it'll say edit at the top right. Click that. We'll navigate down to where it says loop time, check it, and then click apply. We don't have to worry about everything else for now. But yeah, and then if we play, we should notice that it will play that animation, but also just keep playing it indefinitely, which is exactly what we want. You can also notice this with the blue bar here in the animator. It should fill up and then just restart. Now we're also going to transition into making this Xbot lock and run. So to do this, let's go to Assets and then Movement under Animations. And then we should see walking. We should see walking. And then we should also see running. And we want to add those into our animator. So we can just add them like this. However, if you press play right now, you'll notice that the animator will essentially just go through the idle animation, and then it's not going to do anything else, right? It's not going to access walking, it's not going to access running. If you press down the W key right now, nothing's going to happen, right? The reason for this is, again, we haven't told the animator what specific instructions we need it to have to transition from one animation to the other, right? So what we're going to do is we're going to right click on idle and click make transition. So, and then you'll see like you essentially have like an arrow attached to your mouse, and you're just going to click on the animation that you want to attach it to. And do this for making an animation from idle to walk, and back, and then from walk to run, and then from run to walk. So again, that's a transition from idle to walking, and then back, and then transition from walking to running, and then back. Okay? You can check these transitions by just clicking on them to make sure you have the right thing. If you made a mistake also in this, so like let's say I accidentally made run from like another one, or one from like running to walking, or running to entry or whatever, you can just click on it and then press the delete key, and it'll get rid of the transition itself. Okay, so now that we have the transitions that we want, we need to specify exactly what's going to take it from idle to walk, right? We have the transition, but what exactly is the condition for this transition to happen, right? You see here the conditions list is empty if you click on a transition. So what we're going to do here is navigate to the parameters tab in the animator. You'll see it says list is empty, add something, and then we're going to add two bools, or two booleans. One is called is walking, and one is called is running. Please make sure it is spelled this way correctly, just because I have written up some scripts that detect text down to how it's capitalized and formatted, so please make sure they are named the exact same way. What is a Boolean? A Boolean is essentially just a value or a variable that will evaluate to only true or false. So it's either is running is true or is running is false, so you're either running or you're not. Another way to think about it is it's some variable x that will only ever have two answers. And this is really good if we want to say something is either one thing or the other, right? You're either walking or you're running. You can't walk and run at the same time. You're either idling or you're walking. You can't do both at the same time. Now we want to give everything a condition. So first, let's do an example one from idle to walk. we look at the conditions tab. It says empty, so we're going to click add, and you'll see that we want it to be is walking. It'll automatically do this for some of them. And want is walking to be true, right? You want the idle to transition to walking when your is walking is true. Okay. We're going to do this for everything else. So likewise, if we want to transition from walking back to idle, we want it to be when is walking is false, right? You're no longer walking. And do the same for walking to running. So we want transition when is running is true, and transition back when is running is false. Now we want to go back to our Xbot at idle, our idle Xbot. And now that we have our animator set up, we want to apply the script, the core movement script. I believe it is just called movement script, and we can add it down here. And when you press play, let's actually move this animator up so we can see exactly what's happening. When you press W, after a while, you'll notice, okay, after the idle animation has fully played, we will transition to walking. And then after the walking animation has fully played, we'll transition to running. But that looks really, really weird, right? We don't want to wait in idle. I have the W key pressed down. We'll notice the walking thing is turned on, right? It's checked. We don't want to wait until the end of idle to walk, right? We want it to be seamless with player input. So the reason why it isn't is, we'll look here. Within the transitions, you'll notice that has exit time has been checked. What that means is essentially there is a specific amount of time I have to wait, that exit time, before I transition from idle to walking. You'll notice that exit time is here. It'll be a number between 0 and 1. You can think of it as a percentage. So right now I'm waiting for 98% of the idle animation to finish before I transition to walk. We don't want that. We just want it to be seamless. So we can just check off has exit time for everything. Why would you maybe need this? Well, think of a game like Dark Souls, right? Or any game where there's a very long charge up animation that you want to lock the player into. If you set an exit time, you essentially accomplish that. Cool. Now, if we press play, you'll notice that I just walk immediately, and I run immediately, and I stop running immediately, and I stop walking immediately. Walk is with W, run is with left shift. Sorry for not specifying that. But yeah. Cool. So now we've already got a basic sort of character moving around. And that's awesome. So here's another situation. Now that we've gotten the first situation done. Let's say I have some kind of animation that I want to combine with another animation. So let's say, for example, I want a character to jump, and then I want a character to grab onto a ledge. Or I want the character to get hit, but then ragdoll or collapse onto the ground after they get hit. It is a lot easier to have those animations be separate things, right? Because maybe multiple characters need to be able to fall onto the ground, and you only want to create one central generic animation for falling onto the ground. But maybe only one character needs to be able to grab onto ledges, or only one character is susceptible to getting punched or dying or that kind of stuff, even though all characters can fall. How do we deal with that, right? How do we deal with having specific different animations that we want to combine to create one holistic animation? So there's an answer. We'll do what is called animation blending. What we're going to do is we're going to essentially create an animation tied to our Xbot here that shows our Xbot getting punched and then falling to the ground, right? Those are two very different animations, the recoil from the punch and falling to the ground, but we'll show how we can combine them. So to do that, right-click anywhere within your empty animator, and then click on Create State, and then from New Blend Tree. Okay, you'll see it'll say Blend Tree. You'll also notice that it should have created a sort of float variable for you. First, we're going to rename this blend tree to, we can just rename it here in the inspector to punch to stun. Um, you can name it whatever. And then we want to create in transitions from idle to punch to stun and punch to stun to back. These transitions are not a rule of thumb. These are just what I'm using to show you what's, like just like the basics of these systems. But please do note, you do not need to follow these transitions. If you want the idle to be able to go into run, that's perfectly fine. Um, not everything has to go back to idle also. Maybe you can only get punched and stunned when you're running, right? But this is just what I'm showing you for ease of convenience. Cool. Yeah, so within this punch to stun, you can double click to go into this tab. You'll see on the top of the animator. You can click on the base layer to navigate back to that. You'll see that there is kind of like decimal float variable going between 0 and 1 called blend. The reason why we have this is, first of all blend trees must have one or multiple float variables. Float variables are just variables that can be decimal numbers, okay? The reason for this is the way that animation blending works is it essentially will take two animations or multiple animations, and depending on the value of this number, be more heavily scaled or weighted, as it is more commonly referred to as, one animation versus the other. So, for example, here, um, if my blend tree, you'll see here the transition is from punch to stun to idle. Well, okay, yeah. So if let's say hypothetically, idle is at 0 and punch to stun is at 1. So I'm fully idling when I'm at 0, and I'm fully at the punch to stun animation when I'm at 1. What this is going to do is it's essentially going to say, if I am, let's say here, at the 30, like 0.35, it's essentially saying I'm going to be weighted roughly having 65% of the animation be the idle animation and 35% of the animation be the punch to stun animation. So you're transitioning along a gradient, essentially, of this animation, with it being more heavily weighted towards one side or another. And that's why we need this float. Let us rename this to stun time. So just double click on that and rename it to stun time. Again, please keep this naming convention. Blend trees can get very complex, but we're just going to work on this one-dimensional blend tree for now. What we're going to do is in the motion field, click add, and then add motion field. So the little plus sign, and then click add motion field. You'll notice that you can create a new blend tree. So you can blend from animation to animation to animation. You just keep going to infinity. If I have like an animation where I'm trying to pull out a gun and then reload that gun, right? And I have a lot of different parts to reloading, we can have like just new blend trees after new blend trees. Cool. You'll notice that when you add two motions, it'll create this kind of like graph. And you'll see here what I was describing, right? At 0, it's fully weighted towards this animation on the left, and with a 1, it's fully weighted toward this animation on the right. And then you'll see the weight fully starts to decrease, gradually decreases for one and increases for the other. Now, what we're going to do is we're going to add or we're going to navigate to our animations folder. And we're going to navigate from big hit to head to stunned. So drag the big hit to head and then stun in. You'll notice that like here you'll see there's like there's gonna be two different animations now traveling out of your blend tree. And again, just to emphasize the gradient point, you'll see that it'll slowly transition the blue line and the emphasis from one to the other in the animator as well. We're also going to make sure that these aren't looped we need to make sure that these transitions know the condition that we need. So we're going to add a new Boolean called isPunched. This is essentially will determine the transition from idle to punch to stun. So we'll go here, we'll click plus. We want it to transition when isPunched is true. We want to transition back when isPunched is false. Okay. I actually misspoke. That's on me. What we're going to actually need to do is actually delete this isPunched value. We can just do that by pressing the delete key. Delete the parameter. What we're actually going to do to transition is we're going to be using stun time instead. So we're going to click on stun time, And we want it to transition when stun time is greater than 0, and transition back when stun time is less than 0.05. You can choose any arbitrarily small number, but you don't want it to be necessarily 0, just because sometimes depending on specific, I guess, ways that you're manipulating numbers or floats, it might not necessarily reach exactly 0. You just want to be careful about that. And then we're going to have to set it to not have exit time to make sure it'll play. And then now it should be that when we press play and we press F, you'll see it'll go into like essentially a punch animation and then a stunned animation. Yeah, like that. And then it'll slowly transition up. You can click into it, the punch to stun animation, to see this in play. So we click F. You'll notice it fall. And then get up. Unsure about why this is not changing in the parameters, but it is definitely changing, just because this would not work as an animation. Otherwise, you can also see it in the console, what it's saying, how it's changing in the console. But yeah, and this is how you can create animation blending. You'll notice that, like, it's a bit weird the way that this model gets up. So this is a place where you might need to do another blend tree, right? So in punch to stun, I might need another blend tree from stunned or something like that, or another blend tree here. And that blend tree is like a getting up animation, right? And yeah, that is the basics of animation blending. Now, on to our next aspect. Let's say, okay, so now we already have this character that sort of walks in like a relatively straight line. But how exactly do we get this character to walk in like a 3D sort of space, right? This is not 2D animation where you only have to go left and right or up and down. We want to be able to walk in whatever direction that we so desire. So this is where multi-dimensional blending comes into play. This is crucial for most movement and aiming and anything in between, especially in 3D. So here's what we're going to do. Let's go to our base layer, and we need to create a new blend tree. Let's actually move everything here. So let's move all of this up a little bit. We need to create a new blend tree, and we're going to name this blend tree 2D movement. Cool. And we want to change the default animation state. You'll notice that idle is in orange because it is the default animation state. It goes from entry, so on play, to the idle animation. We want to reset that, so we want to right click on 2D movement and then click on set as layer default state. And you'll notice that 2D movement is now red. Oh, sorry, orange. Cool. If you look at it, if you click into it, you'll notice that this looks pretty similar to our previous blend tree. Doesn't look like there's really anything different about this. And the reason for this is we need to click on the blend tree and change the blend type from 1D to 2D freeform directional. All right, so I'll give a brief explanation of these separate animations. The 2D simple directional works if you have maybe like it's for simpler animations. So if you only want to walk in 360 degrees, but you don't necessarily need to run or sprint or strafe, then this is a good way to do it. 2D freeform Cartesian is for aiming, so in a spherical pattern. 2D freeform directional is like you're still like kind of walking on the ground, right? But 2D freeform Cartesian allows for like aiming inputs if you're holding a gun and you want your model to move along with that gun. And direct is like for facial expressions, like if you want to animate faces, that kind of stuff. Cool. Awesome. What we're going to do is we're going to create two float parameters. We're going to name one X velocity. We're going to name one Z velocity, the planes of movement. Make sure, again, the naming conventions are correct. And then for our blend tree, you'll see here that there are parameters, and they're both set to stun time right now. So we want to set one of them to X, the first one to X, sorry, and the second one to Z. And you'll see it update here. Awesome. Now, what we want to do is we want to create a bunch of motion fields. We are going to need, I believe, exactly 7. So you notice, as you add motion fields, you'll have sort of a graph appear. We just keep going until we have 1, 2, 3, 4, 5, 6, 7. And you'll notice that this is kind of like what the graph looks like now. And let's just zero everything out for now, just for simplicity's sake. And then we're going to apply a bunch of animations to these motions. So what we're going to need is click into the movement folder. We're going to need walking. We're going to need running. We're going to need a walk left strafe, a walk right strafe. We're going to need a run left strafe and a run right strafe. And then you can move different hierarchies. But we're going to move this last one up, and we're going to apply the idle animation, which is just in the overall animations folder. So this is what it should look like for you now. And then we're going to assign it different values. I will explain why we do this in a bit. So we're going to have walking be 0.5, run be 0.2, or 0.2, sorry. Negative 0.5, 0.5 here, -2, and 2. So your graph should look something like this. And you'll notice, like, as you click through different things, it'll look slightly different. So why did we do this? This is because our velocities, x velocity and z velocity, have sort of become, you can think of them as the axes of this motion graph. So if we apply a certain velocity to it, so if you apply a certain x velocity to it, you can click on the red dot to move things around. It'll essentially transition towards walk, so from idle to walk, and then as we keep going from walk to run. So depending on the velocity that we're applying, we can transition between all sorts of different animations. We can be in between, running to the left, or running straight, and even have like a little bit of walk in. So doing this gives us like a very high degree of flexibility. You can see it down here actually. When we press play, you can see like it slowed down as I drag the node a little bit closer. You'll see, it's running drastically to the left if we do it like this. And then it slows down a little bit back into like a walking to the left and then back to idle. So with just like a few simple clicks, we've created a whole walk cycle for our character. And yes, this allows us to transition smoothly between any kind of radial movement. You can also see it here with like this kind of like blue highlight. If you click on the different motions, you'll see it'll show these kinds of blue highlights. And what it essentially shows is the region that it controls. If I move the red node here, you're going to see parts of the idle animation. Okay. If I click on running, you'll see that running will not, like the straight running will not really apply, but it will be applied strongest here. So now that we have all of this, let's just pause this. We're going to navigate back to our Xbot in idle. And what we're going to do is go to our scripts folder and drag the blend movement script over and turn off punch script and movement script. And then if you press play, you'll notice that I can walk, I can run, and I can also, if I press W, A, and D, I can run in different directions if I so desire. I can walk in different directions if I so desire. I can essentially do any kind of movement that I want. And it transitions back and forth very, very smoothly. Awesome. So yeah, and that's just a really simple way of creating full 3D movement. Now we're going to cover one last topic, one that I talked about a little bit earlier, which is animation retargeting. What are we going to do if we have an animation that we created, we have a jump animation, and we wanted to apply it to our Xbot here, but we originally created the animation for another model. Okay. So we already have something like that here. So what we're going to do, we're going to go to our jump folder and we're going to just drag the boss animation in, and then we can move it a little bit to like the left of the Xbot or the right of the Xbot from our perspective. The reason why it looks really white right now is because the textures are not applied correctly. What we're going to have to do is we're just going to have to click on the boss in the projects folder, go to the inspector, and where it says extract textures, just click that button and put it anywhere, fix whatever that is. And yeah, now we should see it normally. Don't worry about that. We'll go over textures and materials in another workshop. Let us now navigate to animators, right click, create, Animator Controller, and then let's name this jump animation. So if we click into this, let's go to our boss here and apply the jump animation. Navigate back to the scene. So if we go to the boss and then we apply this animator, the jump anim, so just drag and drop into the boss. And now we press play. We should see that the boss is just jumping normally. Cool. However, let's navigate back to our Xbot. Let's turn off the blend movement script. And change the animator to the jump animation. Or the jump animator, my bad. When we press play, we'll notice that for some reason the Xbot is not really jumping. So we need to essentially retarget this animation so that the Xbot can also use it. What exactly does that mean, right? I've been talking about retargeting this whole time. What this means is essentially right now, the joints for the Xbot and the joints for the boss are very specific, right? You see it says here it's boss hips, boss left leg. This is Miximo rig hips, etc., etc. We need to abstract that so that Unity will recognize, oh, whenever you just have hips in the name, you mean any kind of hips. Whenever you say left leg, you mean any kind of left leg. That way, if we make the Xbot generic and the boss generic, instead of it reading as boss hips, and we're trying to apply that to the Xbot, so we're trying to see if the Xbot has hips of the boss model, which of course it will never have, we instead look to see if the Xbot just has any kind of hip joint, okay? So instead of doing boss hips, we're just doing any hips. And because the Xbot has, any hips, the animation will be successfully retargeted. Cool. So to do this, another way that we can see that this is happening also, is if we click on the Xbot, I believe, and we open up the animation tab, you'll see like that it's saying like a bunch of these quote unquote boss joints are missing, because of course they're going to be missing, right? You're not going to have any boss joints attached to the Xbot. However, again, if we can essentially just get Unity to clip out anything that says, anything before the colon, and it'll give us exactly what we need. Cool. To do this, what we're going to have to do is we're going to need to abstract these models, go to where you are in, let's see, yeah. Okay, go to your Xbot idle, go to the rig tab in your inspector, and change the animation type from generic to humanoid. We want this to be a humanoid model. And then we want to create an avatar definition from this model and click apply. Cool. Now what you should see is you should see a general avatar, like a little person get created next to the idle animation. And we want to do the same for the boss. So navigate to the jump folder, click on the boss, rig, humanoid, apply. Yeah, we should see the boss should also have a little general guy here. Cool. So if we want to see if this has been set up correctly, what we can do is, let's look at the Xbot. It might be a little bit clearer. Um, is what we can do is we can click on this little avatar and we can click on configure avatar. And you'll see here, it'll bring up like the whole hierarchy of bones and joints and everything here. You can click on them specifically to see what they are. You'll see like that essentially Unity has like a generic hips sort of joint that it has applied the Miximo rig hips to. This is also where you can fix any issues, right? So if this didn't exist and you're like, wait, but my model has it, what you can do is you can just navigate to your Xbot bot and then you can drag and drop that value in, all right? You can also do it more generically, like if there are specific head features, like if its eyebrows need to move, for example, or its jaw, you can do that. The same with the hands. So that's the mapping. You can also change the muscle settings here. So if you want the arms to be able to twist more, you want the arms and legs to be able to stretch more, etc. You want the spine to be able to curve more. You can also change that here. It might not show immediately. Let's find one that actually will show immediately. Yeah. So open close controls like how bendy the spine can be, as you can see here. If it's opened or closed. So you can do that here. We can reset everything. And then yeah. That's just if you want to check if it's correct or not. Now, to make sure that this change has been applied, what we're going to have to do is here you'll see that in the Animator tab, it'll say something that says Avatar. We're just going to drag in the corresponding avatars. So for the boss, we're going to drag in the boss avatar. And then for the Xbot, we're going to drag in the Xbot avatar. Or sorry, yes, the Xbot avatar. Cool. Now, when we press play, you should see that there is some animation that plays. It is very different and weird compared to what we were used to. Now, why is that? The reason for that is because of root motion, the thing that I was talking about earlier. You'll see here that, oh, also let's set this jump animation to loop. My bad. So jump, edit, loop time, apply. The reason that it moves this weirdly is because you'll see that in each of these animators, we set it so that no root motion is applied. However, this jump animation has root motion, right? I'm jumping up. There's that sort of core motion to it. So if we click these two boxes, apply root motion for both of these, and then we click play, we'll notice that instead of like kind of weirdly jumping in place, that these characters are now jumping exactly how they should. And that is animation retargeting. So those are all of the basic components of animation that I'm going to go through with you guys. As a final task, find a character model that's interesting to you and see if you can pull together or create a whole sort of animation set that embodies that character. You know, maybe you want to animate Cloud from Final Fantasy and you want to animate a sword swing, right? If you want to animate like a very giant bulky character, maybe you look for a walk that embodies that. See if you can slow it down. You can slow down certain walks, speed them up, and all of those kinds of things to sort of embody that model that you've chosen. And yeah, that's it. Awesome. Thank you.